Hi there, my name is Miss Townsend and I love math. Welcome to Math with Townsend. This video is for my grade 12 students who are working on the statistics unit. We're going to look specifically at how to find the statistics when your data has been grouped. So here's the data file that we're going to work with. And what we need to do is we need to find the mean, the median, the mode, standard deviation, Q1 and Q3 so we can find the IQR. We need to do an outlier check, and we're going to draw a box and whisker plot. So before we do any of the actual math for those statistics, let's make sure we can clearly understand what this information is. So we have a bunch of data about how much storage space in gigabytes has been used on a set of devices. And so someone already sort of organized our data for us, and we need to make sure that we still understand the data, even though we don't have all the actual raw data laid out in front of us. So the first thing is, we know that we have 8 pieces of data that are between 0 and 20, but we don't actually have the data in front of us to know how many of them were 0, how many were 20, how many were 17, and so on. So the way to deal with that is we treat every single piece of data within that zone as if they were right in the middle of 0 and 20, which is 10. So again, the 8 pieces of data that were in the zone 0 to 20, we're going to pretend that they're all 10. Same thing with the next one. We have 12 pieces of data here, and we're going to pretend that they're all 30. So again, what I'm doing is I'm taking the midpoint of that interval. So the interval between 40 and 60, the midpoint is 50. So every one of those 35 pieces of data is going to be treated as if it was the number 50. All of these are going to be 70, so the midpoint is 60 to 80. Here, those will all be treated as if they're 90, and these will all be treated as if they're 110. Now again, I don't actually know if any single piece of data was actually 10 or 30 or 50, 70, 90, 110. But that's the best we can do with the information in front of us, is just take the midpoint of the interval. So from now on, instead of using this as my data file, as the information I have, I'm going to use this. Oops. This. So this is now, I've updated the storage used information to reflect the midpoint of the interval. So the next thing that's really important to know is the frequency part. And I've already talked about this briefly, I've mentioned this, that there are 8 pieces of data that say 10, 12 pieces of data that say 30. So the first thing you're going to want to do is get an idea of how many pieces of data are there. Well, if I add up all the frequencies, there are 138 pieces of data here. So that's why someone organized the data, because it's not very much, it's not a really exciting existence to start writing, well, this piece of data occurred 8 times, and then this piece of data occurred 12 times, and keep writing it. This piece of data occurred 35 times, this piece 45. So it's kind of nice that someone organized it for us, but you'll see why sometimes you don't like that either. But that's the first thing to do, is to first of all make sure that you get all your midpoints so that you're not worried about the range. It's now 10, and we no longer are ever going to concern ourselves with the 0 to 20 information. And also to make sure that you see all the frequencies, and there's 138. So the first thing I recommend that you do is to take out your scientific calculator and enter the data. So obviously, because we all have different scientific calculators, it's not going to do me any good to actually go through that in the video. Don't forget that because there's 138 pieces of data, you do want to be able to enter 10 pieces of data 8 times without having to press that M+ button 8 times. So make sure you're comfortable with that. So I'll just give you those. And again, that's definitely something you need to see me at school if you're still not sure how to do that. So when you calculate the mean, you should get this value. And yes, there was a typo in the answer sheet at 66.087, and the standard deviation is 26.4694. So again, both of those pieces of data are just straight calculated using the statistics mode in your handheld scientific calculator. So I'm not going to go through that on the video, but let's go through the rest of the stuff. The first thing is, let's do the mode. Okay, so mode, hopefully pretty straightforward. It's the most popular piece of data. So there are 45 pieces of data at 70. So the mode is 70. And again, I'm not ever referring to the 60 to 80 that we saw originally. I'm just purely treating that as if it was 70, and I'm not going to go back to that other one. Mode, we understand mode. 45 pieces of data, that's more than any of the other frequencies, so there's our mode. But I think probably the reason why we wanted to make this video was to talk about median and the Q1, Q3 quartiles. So first of all, let's think about how would we find the median of 138 pieces of data. So I'm just going to give myself a clean screen here. Again, you know, I'm presuming you're in my class if you're watching this. You know that I'm a very visual learner myself. That for me, I like to lay it out. So I'm going to imagine that this line represents the 138 pieces of data written out, all 138 of them, from the smallest over here to the biggest over here. And that's a visual line just so I'm sort of seeing the data. The median is, so we know that the median is the piece of data exactly in the middle of the data, so that half the data is below it and half the data is above it. So what's the middle of 138 pieces of data? So if you do 138 divided by 2, you get 69, but the 69th piece of data is not my median, and here's why. If I just take the 69th piece of data, that means I have 68 pieces of data before it and 69 pieces of data after it. And that's not, therefore, exactly in the middle. So the thing I've always suggested that helps no matter what is when you take your calculator, if you're going to take your calculator and divide the number of pieces of data by 2, always add 0.5. And that tells you precisely where to look for your middle. So what that 0.5 tells me is that my median is halfway between the 69th piece of data, sorry, that's a little messy, and the 70th piece of data. So I need to find the 69th piece of data, and I need to find the 70th piece of data. That's going to tell me where my median is. So let me just make that a little neater. So here's where the median is, capital M for median. And there's going to be 69 pieces of data before it and 69 pieces of data after it. That visually I can see. I can also see the numbers. So that means I need to figure out what is the 69th piece of data, what is the 70th piece of data, and then I'm going to find the midpoint of those two. So how do we find the 69th and the 70th if our data looks like this? So what we need to do is we need to really investigate further into this frequency idea. So the first piece of data, x1, is here because it's the lowest piece of data. And then if there's 8 pieces of data, then x2 is here, x3, x4, all the way up to x8. So if I ever needed to find any of the pieces of data between 1 and 8, I know where to look. They're right here, there would be 10. So the next interval starts, therefore, at the 9th piece of data, and it goes up until what piece of data? And this is really important because we need to add 8 and 12 to get the answer, which is 20. And if you're not sure why that works, just consider this. You can always just count. 9, 10, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So I just counted all of these pieces of data, and I counted 12 pieces of data. So if you did 9 plus 12, you're actually going too far. You always want to use this one, the end of the last interval, and add it to the frequency. So to keep going, if this interval ends at the 20th piece of data, then the 21st piece of data is here, and this would now go till 20 plus 35. The 55th piece of data would be here as well, which means the next interval is the 56th up until 55 plus 45 is 100. So the 100th piece of data is in this interval. Then we have x101, so the 101st piece of data up until 100 plus 20, the 120th piece. And then 121 120 plus 2, 138. And of course, it's all good that we found the 138th piece of data, no more, no less. So now I know where to find every piece of data. So what am I looking for? I'm looking for the 69th and the 70th piece of data. So look at this interval here, and I know it's very messy. Let's see if I can clean that up without causing too much chaos. This interval right here, the 45 pieces of data I've just highlighted are the 56th piece of data, the 57th piece of data, the 58th, 59th, all the way up to the 100th. So if I need the 69th piece of data, I look in this zone, it's 70. If I need the 70th piece of data, it's also here, and it's also 70. So that means, obviously, if I found the midpoint between 70 and 70, I know that the median, capital M, is 70. So that's how I can get the median. So if I go back here, now we know that the median is 70, and we now have, and I'm going to give myself a clean page here. So we know the median's at 70. And we know we have 69 pieces of data in the first half and 69 pieces of data in the second half. So now, to find Q1, I look only in the first half, and basically I want the median of those 69 pieces of data. So right about here, I need to find the median. So again, just like I would for the true median, this is the median of the first half, I'm going to do 69 divided by 2 in my calculator, and that gives me 34.5, and then if we do that trick, add a half, we get 35. Oops. So I want the 35th piece of data. So, and then again, let's be sure. So if I take exactly the 35th piece of data, that means there's 34 pieces of data before it, and hopefully 34 pieces behind it. So 34 plus 34 is 68, plus the actual value, which is a piece of data. Those are my 69 pieces of data. So I know that Q1 will be the 35th piece of data. So let's go find it. Where's the 35th piece of data? So if you look at your letters here, the 21st piece of data is here, and this zone goes up to the 55th. So 21, 22, 23, somewhere in there is the 35th piece of data. So 50 is the 35th piece of data. So Q1 equals 50. And now we're going to do something similar to find Q3. So we already know that this 34 idea is important. So, but what I'm going to do is I have to figure out what exactly that piece of data is in this half. So again, you can always just like sort of count it through, but we know that just before here was the 69th piece of data. So if I move 34 pieces above that, actually, sorry, 35 pieces above that, I would be at which piece of data? So 69 plus 35 is the 104th piece of data. And I always check. It doesn't matter how many years I've been teaching this, I always check. 104, so we know the last piece of data is 138. So 138 minus 104, that would give me 34 pieces of data here. And then there'd be 34 pieces of data here. So 34, Q1, 34, the median's not a real point. 34, Q3, 34, those are all my pieces of data. So I need to find the 104th piece of data. So I go back here. Oops. Uh-oh, where did I put it? I go here. The 104th piece of data. So here we have data piece 101 up to 120. So 104th is in here. So it's 90. So now I know that Q3, I don't know where I'm going here. I'll just get to a clean sheet. So we found that Q1 was at 50 and Q3 was at 90. Okay, so now I can find the interquartile range, which is found by just subtracting Q3 minus Q1. So the interquartile range is 40. So the middle 50% of the data only has a spread of 40. Now we need the interquartile range to do the outlier stuff. So we know that the formula for the lower outlier boundary is Q1 minus 1.5 times the interquartile range. So in this case, Q1 is 50. So 50 minus 1.5 times 40. So 1.5 times 40 is 60. Oops. So 50 minus 60 gives us negative 10. So if we had any piece of data below negative 10, it would be an outlier. And obviously we don't, because our data doesn't go below positive numbers for sure. Q3, the formula for the upper outlier boundary, very similar. It's Q3 plus 1.5 times the IQR. So in this case, that's 90 plus 1.5 times 40. So that's 150. So if we had any data bigger than 150, it would be an outlier. And again, if we look at our data, nothing's too low and nothing's too high. So we have no outliers. So let's go ahead and draw our box and whisker plot. So in order to draw the box and whisker plot, you need to have already checked for outliers, and we did. There's no outliers. Since there's no outliers, the 5 numbers I need are the minimum, which is 10, Q1, which was 50, the median, which was 70, Q3, which was 90, and the maximum, which is 110. It's not going to be a very exciting box and whisker plot because we have such small variability in our data. Oh dear. Okay, so I'll use that as my axis. 10, oh dear, sorry. So I'll go up by 10s, 10, 20, 30, no, 10, 20, 30, 40, 50, 60, 70. Oh dear. I would be so angry if anyone did this in class, wouldn't I? Oh. So first of all, I'm under labeling because it gets really messy really quickly. But what the heck? There we go. Arrows. Arrows. Usually I like to label one more than I need. So we draw a box and whisker, and again, this is going to be terribly messy. I kind of hope no one's actually watching this. Q1 is at 50. Q3 is at 90. So Q1 and Q3 are what formed the box of the box and whisker. Oops. Uh-oh. Try to erase that, and it's not working. Erase. Thank you. Then, in the box, we put our median line, which in this case is at 70. There's the median. And then the whisker goes up to the maximum and down to the minimum. And of course, you're using a ruler. You're putting a title like gigabytes, like storage used. That's a perfect title. And then down here, you're putting gigabytes of storage. So you always put the units down here. So it's terribly messy, but I think most of you, if you're here, you were here to figure out, to have a look at this stuff, because that's the yucky part of group data. Anyway, I hope that was useful. Bye.